So hi everybody, my name's Tom. I'm here to talk to you a little bit today about my company Art Marine, which I founded about 8 years ago. So the mission and vision of Art Marine is to accelerate reef creation. And so I've got to start with a bit of bad news before I get to the light, right? Which most pitches do. But this is currently what our seabeds look like around the UK and also around the world. So this is an area of the seabed which has been completely destroyed, primarily due to bottom trawling, something we call ocean sprawl, which is the equivalent of urban sprawl. So sort of humankind sort of encroaching into the marine environment. And what it's led to is 95% of our native oysters being destroyed and over 50,000 hectares of seabed being destroyed every year, which is, mind-boggling when you think about it. And so me and a group of divers who were normally diving recreationally had seen this firsthand, and we wanted to understand how we could repair it. So we started looking at things like shipwrecks. Can we sink a ship, colonize that area of the seabed and bring life back? And it wasn't until I started my life as a commercial diver, so that means sort of the inshore civils work, ports, harbors, chains, moorings, all the sort of boring infrastructure that happens around the harbor. Not as glamorous as you think, honestly. It's a cool picture, but it's not like that every day. And what was super interesting, sort of super scary, is my dad was a diver as well. So he dived for an environmental company, and my granddad and my uncles had been divers in the Navy beforehand. And in this small family from Devon in the UK, we'd witnessed firsthand degradation. So my granddad, fish everywhere, brilliant, absolutely great. My dad, we catch some fish every now and again, and it's great. And me, it's like, nothing. When I dive down there, it's like a barren seabed. So that was a bit of an eye-opener when I'd have these conversations with my family. And it was during my career as a commercial diver, I learned about this problem, which is a problem that not a lot of people are aware of because it's out of sight, out of mind, under the water. But since the 1970s, every offshore construction project has been deploying products like this: plastic bags filled with rocks, artificial seaweed, plastic subsea cabling. And they need to protect it, right? This is critical infrastructure. It needs to be protected. And unfortunately, they're using these materials which are causing a huge amount of harm to the environment. So I've come across these products in my working life, and I thought, well, we're putting things into the marine environment. We're buying these products. We're deploying them on the seabed. How can we improve this product, this design, to actually improve the marine environment at the same time? Because then you've actually got an active solution to what's going on. And so to give you an idea of these numbers, a single windmill, which is supposed to be green energy, and it is, they can have up to 10 tons of plastic around a single monopile, which can be ingested by marine life, can be buried into the sediment, it can be completely lost. So for the past 8 years, we've been developing a product called reef cubes. So reef cubes are an artificial reef unit. They range in sizes, so 30 centimeters, which are about the size of this cube. They weigh about 5 kilos, but all the way up to 1.5 meters weighing 6 ton. So the units you see on the left are for a coastal defense project. And what we've done is we've designed a material that's perfect for marine life. So it's carbon neutral, it doesn't contain any Portland cement. It's 98% recycled. So we're using sand and aggregates from coring industries like clay and granite mines. And then we've also got this really clever way, the science team have got a really clever way of actually engineering the surfaces that mimic natural surfaces as well. So there's a lot of scientific work that's gone into colonization rates and how do we make the perfect substrate for life to settle on. And there's a few pictures here, but I'll go into some more in the meantime. But what Art Marine has become is, as what I describe now as an eco-engineering company, which was never my plan. I'm not an engineer. And so we've got sort of two main disciplines. One is the environmental engineering, which is sort of the marine biology. How do we make the structure work for the fish, the marine life? And then also, how do we make the structure work for the offshore wind turbine guys? Because they're the ones that are going to be buying it. So it has to fit this primary purpose first, but then how do we make it as ecologically friendly as possible? And this is a process which goes on and on and on. And so what Art Marine does is they design, they build, they deploy, and then they monitor. So that means that we can actually track the whole progress, understand how it's working, go back, redesign it again, make it better, and go through that whole process. So it's a really new space. It's sort of defined as like nature-based solutions or nature-inspired design. And it can happen on land, it can happen underwater. But we're really happy about this bit. This is why we do it at Art Marine, which is the impact side of things. So we've installed over like 1,200 units in UK seas, Dutch waters, Sweden. We've got projects planned on the east coast of the US, as far as the Middle East, like the UAE and Fiji. And so what that means is that we've now got a global market to help restore the marine environment, which is what we haven't had before. There's a huge amount of infrastructure which is going to be going into the water. And this for us is like the perfect opportunity to actually restore it. So some really cool pictures here. This is from one of our first reefs that we deployed in the UK. So it's in my hometown, Torbay, Devon. This area was devoid of life, completely trawled. And within, these pictures are all taken in less than a year. So we've got brown crab, edible crab, which a lot of people eat. We've got juvenile cod around the structures. We've got blue mussels, loads of different crabs. We had a game which is like, how many crabs can you see? And you've got like 1, 2, 3. And then we've also got whelk eggs as well. And then sort of sponges here, primrose anemones. So what we've proven through peer-reviewed science is that these reef cubes are working as nursery and spawning grounds. They're working for juvenile fish. They're working for commercial fish stocks. So it's a big plus for the fishing community. You know, we've got hugely overexploited fish stocks, but also it works for water quality as well. So blue mussels are constantly filtering through water, increasing turbidity, which means light penetration gets down. So there's all round ecosystem services which you get, which we haven't had since, 50 to 100 years of industrialized fishing. And so how do we scale this is becoming, the next stage of the business, right? So we raised over £2.5 million in equity funding. And now what we're trying to do is have a mobile manufacturing plant, which basically you containerize it, you put it on a ship, you transport it to a local dock, a local port, you manufacture the amount of reef cubes you need for a project, hopefully utilizing local workforce, local materials if they're suitable, and then you pack it up again onto the next location. And so we want to have at least 12 of these manufacturing in a box setups planned around the globe so we can target all these industries as we go. So the exciting thing for me is the scale that we can get to with this. So there's been a lot of offshore reefs deployed. So the Japanese have been doing it for like 1,000 years. And what we've witnessed is that they've always been sort of unconnected. So you'll get someone do a reef project in the UK, and then you'll get 5 years later someone doing it in the US, and they're not really sharing the learnings. They're not really connected. Nobody really knows how well the other project has gone, and there isn't like a common metric that can be compared. And so what's super interesting is that there are 30,000 monopiles, so the stick that basically holds the windmill up, are going to be installed between now and 2035 in the offshore transition. And around a single turbine, you can get up to 40 to 50,000 of the smaller reef cubes. So this is a huge opportunity for every single monopile to have these reef cubes, sequester carbon, reboost our reef ecosystems. And now we've got policy and regulation sort of mandating that. So there are new policies coming out, biodiversity net gain, marine net gain, which basically says, if you're going to build in the marine environment or in the coastal environment, like a breakwater, we want to see whatever space you're taking up, plus 10% in habitat enhancement or marine benefit. So now we've actually got policy driving this, which is exactly what we needed, right? Because, people see it as a nice to have still. Yeah, it's, we're building a wind farm, it'd be nice to have a reef. But the minute you have the policy, it then becomes, mandated. So now we have that. And then finally is the carbon and biodiversity credit space. So 8 years ago, this was nascent to me. I had no idea what it was. And it's only just recently where carbon and biodiversity credits is actually becoming a thing for us, and our products might qualify for it, which means we can actually make reef cubes lower than the cost of the traditional technology. That's been a big problem, right? That green premium that often exists. The eco-friendly option is always more expensive. It's done in smaller batches. It's not at scale yet. So for us to actually become cheaper, it might now become a reality before we actually scale, which again is really, really cool. So this is my final slide. It's one of our reefs, as you can see. And I think to share with you a little bit about our vision is we now see the opportunity to install over 1 billion reef cubes between now and 2040 in every ocean across the globe. And so hopefully now you're a little bit more aware about what we're doing, what the state of the oceans are, and hopefully you can support us on our journey. Thanks.